Right, let's have a look at some applications with logs. Okay, so here is an equation. So the walking speed depends on the population of the city, and here's the equation, okay? So it just wants to know probably what the walking speed is for different populations, okay? But we're going to use this equation. Right, here is the population of Billings, Montana. So again, what's the walking speed? It's the population of Chicago. Now the equation is actually in thousands, okay? So this is 106,000, so 106.954, so that's what they've put into the formula. Remember, this is purely calculator. You don't have to manipulate anything, it's just putting numbers into a calculator. If you put all that into your calculator, now again, be careful. You might want to do the log first, then multiply by 0.37, then add 0.05, because you're never sure how you put it into your calculator. Okay, again, 2,714,000 is 207, so 2714.856 thousand people, because again, the equation's in thousands. So again, but it depends, every question is different, okay? But what I'm trying to get at this is you're just putting numbers into your calculator, okay? Check those if you want to. Right, another application. Okay, now this is actually earthquake. This is a good one, is this, because this is a realistic situation. I0 is the, what's called here, is the weakest earthquake. It's the minimum intensity for comparison, okay? So something that has maybe 10 times the power, 100 times the power, okay? In this example, the earthquake was 10 to the power 9 bigger than the minimum intensity, okay? It's a lot. Now, that's going to give us a Richter scale, this was what the question's about, of 9 on the Richter scale, okay? Again, if we put this into the equation, so, again, remember, the intensity of the earthquake over the minimum intensity, and we log that, okay? So it's a log question. So here it is, here's the intensity of the earthquake, it's 10 to the power 9 times bigger than the minimum intensity, these will cancel, okay? So what's the log of 10 to the 9? Well, it comes out to be 9. And there is actually a little rule for this. Actually, we're going to learn a new rule. So it's this. Now remember this. Okay. Log to base 8 of 8 was 1. Okay. Because 8 to the power 1 will give me 8. Now what's log to base 8 of 64? It's 2. Because 8 to the power 2, 8 squared is 64. But 64, I can write as 8 squared. 8 squared. Okay, there we go. Now can you see what I'm saying here is if these two are the same, the answer is the exponent. Okay, because look, 8 is 8 to the power 1. Okay, so log to base 8 of 8 to the 1 is 1. Log to base 8 of 8 to the 2 is 2. Okay, so I'm going to write some generalizations here. Here's kind of what we learned so far. So the log to base 10 of 10 is 1 because 10 to the power 1 is 10. Okay. Log to base 10 of 1 is 0. Anything. When you log 1, you get 0 because anything to the power 0 is 1. Here's a new one I just showed you. Log to base 10 of 10 to the 5 is just 5. It's like saying if those two are the same, it's just the exponent. Okay. So again, this box here is just a generalization. Doesn't matter what the base is. Okay. So log to base a of 8 is 1. If these two are the same, you get 1. Remember? It's okay here. Okay. Log to base a. Doesn't matter what the base is. If you log a 1, you get 0. Anything to the power 0 is 1. And here we go. Again, if these two are the same, okay, the answer is just the exponent. Okay? So that's just some general rules for logs.